That is also will come under rule 1 only. Your rule 1, when q of x in the form of hyperbolic, I will write hyperbolic function, that is either sine hax or cos hax. When it is sine hax, we can write it is equals to e to the power of ax minus e to the power of minus ax by 2. If it is cos hax, we can represent e to the power of ax plus e to the power of minus ax by 2. Yes, Aditya, it's clear. When it is in the form of hyperbolic function, sin hax or cos hax, we can represent that in the form of e to the power of ax minus e to the power of minus ax by 2, or cos hax is equals to e to the power of ax plus e to the power of minus ax divided by 2. Yes, shall we see one problem based on this?
Yes, ma'am.
Yes. Write down the problem. Solve d square minus 3d plus 2 of y, which is equals to cos hax, which is equals to cos hax. Already it is in operator form, so directly we'll move for writing the auxiliary equation. Auxiliary equation m square minus 3m plus 2, it's equals to 0. This 3m, how we can split? 2m and m we can write, because a constant here it's a 2. So it's m square minus 2m minus m plus 2, it's equals to 0. From first two term, m is common, m of m minus 2. From here, minus it's common, it's m minus 2, it's equals to 0. M minus 1, m minus 2, it's equals to 0. M minus 1 is equals to 0, or m minus 2 is equals to 0. M, it's equals to 1, m, it's equals to 2. So the roots are real and distinct. The roots are real and distinct, where your complementary function y suffix c is equals to c1 e to the power of m1x plus c2 e to the power of m2x. Y suffix c is equals to c1 e to the power of x plus c2 e to the power of 2x. Yes, Aditya, till here it's clear for you. Now we'll go for to find pi. You are there, Aditya?
Yes, ma'am. Yes, ma'am.
To find pi, where your pi is equals to, just use same method equation what they have given, 1 by f of d into q of x, that is your pi formula, which is equals to 1 divided by what equation they have given?
Ma'am, they gave d square minus 3d plus 2.
plus 2, and here they have given cos, no?
Yes,
Cos
ma'am.
hx they
Cos
have
HX.
given. Yes. This cos hx we can represent as it's equals to 1 divided by d square minus 3d plus 2, and this cos hx will be in the form of e to the power of x. What is your a value here? This is the place for a. What is the value here, a?
0.
A, how it will be 0? A is equals to 1.
Oh, no, no. 1, 1, 1, 1, 1.
Hmm. So I am writing directly here e to the power of 1, then plus e to the power of minus x divided by 2. So this 1 by 2, that is a completely constant. I will take out from this one. Completely I will take common. It's equals to 1 by 2 of. Then this 1 by f of d is there, which I will multiply to this both the terms. Or I'll write one more step, no problem. 1 divided by d square minus 3d plus 2 of e power x plus e to the power of minus x. So this will get turns to 1 by 2 completely common, 1 divided by d square minus 3d plus 2 into e to the power of x, then plus 1 divided by d square minus 3d plus 2 e to the power of minus x. So here I got two pi's to find. This will be my pi1 and this will be my pi2, where I will write my pi formula is equals to pi is equals to, it's got change, half into pi1 plus pi2. I'll make this is equals to my equation number 1, because now I need two values. I need the value of pi1 I need, and next I need the value of pi2. After getting this pi1 and pi2 values, I will combine here. When I will do the substitution over here, I will get my complete required pi. Now we'll move for finding our pi's now. First, to find pi1, which is equals to your 1 divided by d square minus 3d plus 2 e to the power of x. What is the value of a here?
1,
A is equals to,
1, 1, 1.
yes. So you're going to put
It
every
becomes by
d.
0, right?
Put every d. It's equals to a, where a value is equals to 1, which is equals to 1 divided by 1 whole square minus 3 into 1, then plus 2 e to the power of x, which is equals to 1 divided by 1 minus 3 then plus 2 e to the power of x. Now what is happening here? What is happening?
Divided by 0.
Yeah,
So we have to.
but you're not going to write it's equals to infinity. It's a case fails, because our f of a it's becoming 0. It's a matter of case fails. When the case fails, you have to multiply numerator. Multiply numerator with x. Numerator with x, and differentiate. And differentiate denominator with respect to d. Your pi1, it's equals to x divided by, now you're going to differentiate this d square. D square differentiation is equals to what?
2D.
Yes, 2d, then minus 3d differentiation.
Minus 3.
Yes, the d differentiation it's equals to 1. So simply we left with the d. What about the constant?
0.
Yes, e to the power of x. Now again we will substitute. Again substitute t, it's equals to a is equals to 1, which is equals to your pi1, it's equals to x divided by 2 minus 3 e to the power of x, which is equals to x divided by minus 1 e to the power of x. So 1 pi value we got now. Even the case 2 is got covered over here in this. Your pi1, it's equals to minus x e to the power of x. 1 pi we got. Now we have to move for the second one. Similar way we'll move to find pi2, which is equals to 1 divided by d square minus 3d plus 2 e to the power of x. Put every d, it's equals to a is equals to 1, which is equals to 1 divided by 1 minus, it is minus, no? Minus x. With the positive
Yes,
x, just now we
minus of
completed.
minus.
Minus x. So here it will be, your a value will be minus 1. So minus 1 whole square 3 into minus 1 plus 2 e to the power of minus x is equals to 5 minute. 5 minute. It's equals to 1 divided by 1 minus into minus, it's a plus 3, then plus 2. 5 minutes. 5 minutes. E to the power of minus x. It's equals to how much it is? It's a 6. 2 plus 3, 5. 5 plus 1, it's a 6. So 1 by 6 e to the power of, sorry, what the hell I have written here? 1 by 6 e to the power of minus x. Your second pi value. Your pi2, it's equals to 1 by 6 e to the power of minus x. Now what we have to do? We have to substitute these values in your equation number 1, where we have written our required pi is equals to 1 by 2 of pi1 plus pi2. In equation 1 we are going to substitute. Substituting pi1 and pi2 values in equation number 1. My required pi is equals to 1 by 2 of minus x e to the power of x, that is the first pi value, then plus 1 by 6 e to the power of minus x. This is the required pi. Now we will write the general solution, where your GS is equals to required solution, it's equals to complementary function plus particular integral y is equals to y suffix c plus y suffix p. Y, it's equals to c1 e to the power of minus 1 we got, plus 1 we got.
Ma'am, 1 and 2.
Okay. Plus c2 e to the power of 2x, then plus 1 by 2 of 1 by 2 of minus x e power x plus 1 by 6 e to the power of minus x, which is the required solution. Yes, Aditya, any doubt in this?
No, ma'am.
It's a clear.
Yes, ma'am.
Okay. And if they have given you the boundary values, what you're going to do the boundary values?
What boundary value?
Initial conditions, if they have given, what you're going to
Oh,
do?
y0. Oh, yes, and then we differentiate it and then just put it.
Yes, good. We will see that problem also. Shall we see it today or?
Ma'am, I have to go for lunch.
Okay, fine. Chalo, carry on for the lunch. In our next class, we'll see.
Okay, thank you, ma'am.
Okay, then bye.
Thank you so much.